Okay, good evening. Here's our lesson 2 for Unit 7, Domain and Range. So our learning target, I can identify the domain and range of a function. So we got to get some definitions. Domain. Domain is going to consist of all possible inputs. Or we know inputs are also known as the x values. The range are going to consist of all possible outputs, or the y values. So whenever we hear a domain, we think of x, range, we think of y. Pairing. Pairing of a function, that's just that phrase that pays, so each input is paired with exactly one output. One output. Each input is paired with exactly one output. So number one, identify the domain and the range. So I know that says it's my input and my output. I know my inputs are x's, my output are y's. Domain and range, so domain. It's just the possible inputs. So what are the possible inputs? 10, 12, 13, 17. That's it. So 10, 12, 13, 17. We put these little squiggly brackets around it for set. It takes some practice to do those, but that's fine. The range, all the possible outputs, or the y values. I'll start with my squiggly bracket. I get 1999, 2399, 2599, 3398. End it with a squiggly bracket. And that's it. Identifying the domain and range. Domain, possible x values, range, possible y values. Number 2, we're going to do that as a U try. Number 3 is a U try, so you guys try those at home or in class tomorrow. Number 4, it says make a table for the function. So we're going to just make a table. The domain of the function, y equals x minus 3, is 2, 5, 8, 11. It tells me the domain. This is my input. The domain is 2, 5, 8, and 11. We have to identify the range. So the range are the possible outputs. When I put 2 in for x, so x minus 3, it's going to be 2 minus 3 is going to give me a negative 1. When I put 5 in for x, 5 minus 3 gives me a 2. When I put 8 in for x, 8 minus 3 gives me 5. When I put 11 in for x, 11 minus 3 gives me 8. And this bottom part, maybe we don't do that all the time. That's fine. We can probably go right to that table. You could enter that on your calculator and get those also. You just have to skip around on the domain. So let's write our domain. Our little squiggly bracket, 2, 5, 8, and 11. Our range, negative 1, 2, 5, and 8. And that's it. So this was our output down here. Inputs and outputs. Domain, x's, range, output, y's. So number 5 is a U try. Down here, functions can also be defined as a rule. Whenever we see the word rule, we're going to think equation. We're going to make up an equation that describes how one variable relates to another variable. So an input, or x variable, is also, as another name, it's called a dependent variable. This is a dependent variable. And the output, or y variable, is the dependent variable. So I don't know if I said this was independent. This is the independent variable. X, or the input, in Input, independent. The output depends on what you put in. Okay, so we're going to write a function rule, and we said this is just an equation. That's what we're going to write for the table that describes what you would do to the input to get to the output. So what do I have to do to get to that output? So if I'm at 0, an input, what do I have to do to get to 2? Well, I could add 2, couldn't I? Now that has to work for everything in there, so let's check. What if I add 2 to 1? I get 3. What if I add 2 to 4? I get 6. Add 2 to 6, I get 8. Add 2 to 10, and I get 12. Just want to make sure that's where they're going. So, what do I do to this input to get to the output? So my rule is an equation. Y equals, that's how our rule is going to start every time. And if I'm at 0, I add 2 to get to 2. 1, I add 3. 4, 1, I add 2 to get to 3. 4, I add 2 to get to 6. Well, let's just say, what if I'm at x? X, I add 2. So whenever we find our pattern, what we do to the input to get to the output, it has to be the same thing. We just write that as an equation. So y equals x plus 2. And you can go double check that. Well, if I put 6 in, 6 plus 2 is 8. If I put 10 in, 10 plus 2 is 12. So that's our rule. So 7 is a U try. You guys try that, or in class tomorrow, come in with questions. 10 and 11. So 10, given the table of values, find the value of A and B. And what we're looking for is a pattern. So what is A? What is B? Well, what do I do from negative 3 to negative 1? How do I get from negative 3 to negative 1? I add 2, and it equals that. If I add 2 to negative 1, it equals 1. If I add 2 to 1, I get 3. So that looks like the pattern. I'm adding 2. So if I add 2 to 3, A has to be 5. If I add 2 to 5, B has to be 7. So A is 5, B is 7. 5 and 7. So we're just looking for that pattern. 11 is going to be a U try. You guys try that, find that pattern. 12, you're in line to buy a concert ticket that costs $15 each. You can buy up to 6 tickets. Write the cost of the function of the tickets as a function of how many tickets you buy. So we want to identify the independent variable, so the input, and the dependent variable, the output. Make a table, identify the domain and range. So I'm going to make a nice big table here. And I'm going to say my input, well, that's going to be the number of tickets that I buy, right? That's the independent variable. Number of tickets. My output is going to be the total cost, the cost of the tickets, right? So it says you can buy up to 6 tickets. So that means I could buy 0 tickets. I could buy 1 ticket. I could buy 2 tickets, 3 tickets, 4 tickets. Make our table a little bigger. 5 tickets or 6 tickets. Well, my input, my independent variable. If I buy 0 tickets, what's the total cost? 0. If I buy 1 ticket, well, it costs $15. So 15. If I buy 2 tickets, 2 times 15 is 30. If I buy 3 tickets, 3 times 15 is 45. If I buy 4 tickets, $60. If I buy 5 tickets, it's 75, and 6 tickets is $90. Okay? So independent and dependent variable. Now it says identify the domain and range. I'll squeeze it in down here. So the domain. What's the domain? 0, 1, 2, 3, 4, 5, and 6. And my range would be 0, 15, 30, 45, 60, 75, and 90. So we're just going to write up a table of inputs and outputs and fill it out. Write our domain and range. So 13 is you try. You guys try that. Come in with questions or try it in class tomorrow. 14 and 15, state the domain and range of each graph below. So when I think domain, I'm going to think how far left or right the graph goes. When I think range, I think how high or how low the graph goes. Or the domain are the x's and the range are the y's. So once again, how far left or right does this graph go for the domain? Well, just where it touches the x-axis, but at -2 it exists. At -1 it exists. At 0 it exists. At 1 it exists. 2, there's range. This goes out forever. So the domain for this would be all real numbers. Goes on forever this way to positive infinity, goes left all the way to negative infinity. This keeps going down. There's going to be x values associated with this. Okay? The range. How high or how low does this graph go? Well, how low does this graph go? I could turn my pencil like this. Does this touch this graph? Well, at some point it will, way out here, right? It'll keep going. Down here it'll do it. So all the way down to negative infinity. How about up? Touches there, touches there, touches there. It's going to keep touching because this graph's going to keep going up like this. So the range, all real numbers. Possible y values. What are the possible y values? Every number, all real numbers. From negative infinity all the way up to positive infinity. Domain, what are the possible x values? Well, from negative infinity all the way to positive infinity. Okay? Domain and range of this one. Domain. Once again, I can use my pencil. Is this graph going to touch? Is there going to be an x value associated way out here? Well, this graph's going to keep going up. It would. What about way back here? Yeah, it's going to keep going up. All the way over this way? Sure, that graph's going to keep going up. So all real numbers. All real numbers. And my range. How high or how low does this go? How low? Does this graph exist down here? No, there's nothing. It would never touch this. Would it touch at -3? No. -2, no. -1, no. 0, it touches at 0. That's how low it goes. This graph only goes down to 0. How high does it go? Goes on forever to infinity. So how do we say that? Well, we're going to talk about range with y values. Y is going to be greater than or equal to 0. So y's are greater than or equal to 0. 0, 1, 2, 3, 4, all the way up. So we can put our squiggly brackets around this if we want. So that's the domain and range off of a graph. How high or how low for the range. Domain, how far left, how far right. 16, 17s are you tries, and then fill out this bottom part right here. Put a big circle around it so we know you watched it. See you tomorrow in class.